In October 2005, NASA's Constellation program chartered the Exploration Launch Projects Office to begin developing safe, reliable, and affordable space transportation systems to fulfill the strategic goals outlined in the U.S. vision for space exploration. Over the past quarter, the team that is designing the Ares 1 crew launch vehicle and the Ares 5 cargo launch vehicle has made great progress on a number of fronts. For example, wind tunnel testing continues to yield early data on aerodynamic characteristics of various Ares 1 designs, particularly that of the integrated vehicle stack with the Orion Crew Exploration Vehicle and its launch abort system. The wind tunnel test series is a complex process that takes a building block approach. A scale model that reflects the current configuration is tested as part of a design analysis cycle. Data gathered are analyzed and changes are made to the configuration. Then, a new model is built and testing begins again. Thus, inputs from each test series build on the previous one. Almost 1,000 wind tunnel runs have been conducted across a range of flight speeds using various sized models at the Marshall Space Flight Center in Huntsville, Alabama, NASA's Langley Research Center in Hampton, Virginia, the Ames Research Center in Moffett Field, California, and Boeing in St. Louis. The team is using this valuable information as it prepares for the first major systems engineering milestone, the Ares 1 System Requirements Review, which begins in November 2006. Another achievement was the Ares Industry Day, hosted by the Huntsville Chamber of Commerce in September. Some 500 representatives from over 200 aerospace businesses attended this networking opportunity, which proved beneficial for large companies needing to fill competency gaps and small businesses looking for partnership opportunities. Participants included reusable solid rocket booster contractor ATK Launch Systems, rocket engine contractor Pratt & Whitney Rocketdyne, Jacobs Engineering, and Teledyne Brown Engineering, among others. NASA is an advocate for small business involvement to help deliver the innovation needed to produce transportation solutions that meet stringent technical requirements within schedule and cost guidelines. As the business side of the launch vehicle effort progresses, the team is pressing toward the first integrated vehicle test mission, known as the Ares 1-1, which is planned for spring 2009. Major test objectives include understanding the flight of the integrated stack with dynamically similar hardware, characterizing the vehicle's roll torque, and demonstrating first and upper stage separation and clearances. The Ares 1-1 flight test vehicle hardware and support tooling are in development. ATK Launch Systems subcontracted this work to Votaw Precision Technologies of Los Angeles. Some of the activities Votaw is conducting include rough and fine machining of the nozzle, CAD design of the throat support housing and throat housing holding fixture, and developing welding procedures. After completing the machining processes, the nozzle hardware will be shipped to ATK, which is located in Utah, where it will continue through ATK's nozzle fabrication processes. By using a 4-segment motor and shuttle inventory for the Ares 1-1 mission, specific performance data will be collected for the new first stage. A 5th inert stage will be added to make the mass and vehicle length close to the actual Ares 1 vehicle. Again, the advantage of using off-the-shelf equipment is that it requires few modifications. The motor is currently stored at ATK, while the forward skirt, frustum, and inert 5th segment are developed. The 4-segment motor will be shipped to the Kennedy Space Center around August 2008 for the spring 2009 Ares 1-1 test flight. Leveraging hardware in the shuttle's inventory is helping the Ares team make rapid progress. The Kennedy Space Center processing facility has the aft skirt from shuttle inventory for the Ares 1-1 mission as well. Reflecting the new launch vehicle's upper stage design, the booster separation motors will be removed and transferred to the interstage structure. Because the BSMs are being moved, ATK will add thermal protection to the places where they used to be installed. In August, the Ares 1 team completed the first in a series of tests that will aid in the design and development of a parachute recovery system for the first stage booster. The recovery system is derived from the current shuttle system. NASA and industry engineers conducted this testing at the U.S. Army's Yuma Proving Ground. The first stage booster tests collected performance data on a pilot parachute, the first to be unfurled in a 3-stage recovery system NASA is developing. The system includes a pilot, drogue, and 3 main parachutes. The pilot chute, which is 11.5 feet in diameter, was packed and mounted inside a 1,500-pound drop test vehicle. Instruments and a recorder were mounted inside the test vehicle to capture data on the speed, weight on the parachute lines, and pressure during descent from an altitude of 10,000 feet. The Ares 1 first stage booster recovery system program is a 2-year effort. 6 additional tests will be conducted through 2008. Tests are also planned for the drogue and main parachutes. The J2X engine, which is an evolution from the Saturn V, will power both the Ares 1 and Ares 5 upper stages. The team is getting a head start on risk reduction through component testing, using hardware in stock from the X-33 program. Using tooling designed and fabricated by the Marshall Space Flight Center, the turbo machinery was disassembled and inspected, and appears to be in good condition after 20 starts and over 2,000 seconds of operation. This early work on the Ares upper stage engine is building to a milestone of testing the power pack, which consists of the turbo machinery and gas generator system planned for next spring at the Stennis Space Center. The J2X testing series includes a full systems test in 2010, followed by flight testing in 2012. As NASA moves toward transitioning from Space Shuttle to Ares operations in September, the last Space Shuttle main engine was test-fired at the Stennis Space Center's A1 stand, which is being handed over in November. Stennis opened another history-making chapter as it began the process of converting the stand to test-fire the J2X upper stage engine and the Atlas V RS-68 core stage engine. From Saturn to Shuttle to Ares, NASA is utilizing its unique infrastructure to verify that its rocket engines are safe and reliable for human spaceflight. The Jacobs-led team with Lockheed and Honeywell is providing the avionics for the Ares 1-1 flight test vehicle, building on proven Atlas V evolved expendable launch vehicle avionics. The System Integration Laboratory is a high-fidelity test bed supporting a test-like-you-fly philosophy that has been an important factor in 79 consecutive successful Atlas Centaur flights. The SIL provides the capability to conduct real-time simulations with real hardware to ensure that it is fully understood before actual flight. Among the items that are being integrated and tested are the guidance, navigation, and control unit. Another step toward flying the first Ares 1 test flight is constructing an upper stage structure that realistically simulates the flight hardware that will come later. The Glenn Research Center is fabricating the 5.5-meter steel tuna can segments that will be shipped to the Kennedy Space Center and stacked into a mock-up that replicates the mast that the Ares 1 will loft. Glenn is also responsible for the overall thrust vector control system that maneuvers the J2X engine within the upper stage, as well as the power system and sensors and developmental flight instrumentation. Again, underscoring its commitment to involving small businesses in the nation's space industry, NASA conducted a well-attended Industry Day in Cleveland to raise awareness of opportunities across the Constellation program's various projects, including the Orion Crew Exploration Vehicle. This event, which was conducted in September, gave large and small businesses a chance to connect and discuss potential partnerships as the agency makes measurable progress in the design, development, and operation of the Ares 1 and Ares 5 launch vehicles. For more exploration progress reports, visit us on the web at nasa.gov/Ares.